Hello guys, welcome to Apex Math. My name is Bino. In this video, we go through question 6 from the March 2025 and 5 mathematics question paper. Question 6.1, we determine the general solution of this differential equation, and the first step is for us to group the dy with all the functions of y on the left hand side, and the function of y that we have is the y minus 5, and on the right hand side we are going to group that dx with all the functions of x, and the functions of x that we have is the x squared minus 1 and the 3x. So on the left hand side we are going to have the dy grouped with the functions of y, and on the right hand side we are going to have the dx grouped with all the functions of x. After that, we introduce the integral both sides and we integrate both sides. The first step is for us to multiply both sides of the equation by dx, and on the left hand side that dx and that dx will cancel out and will be left with the dy, and on the right hand side we are going to have 3x multiplied by y minus 5 divided by the x squared minus 1, and we have our dx. Remember that on the left hand side we have to have the dy grouped with the y minus 5, so let's divide both sides of the equation by y minus 5. What we do on the right we do on the left, so this will be divided by y minus 5, and on the right hand side the y minus 5 and that y minus 5 will cancel out and will be left with 1 divided by y minus 5 dy, and on the right hand side we have 3x divided by x squared minus 1 dx. So from here we can introduce our integral both sides of the equation. On the left hand side we integrate with respect to y, and on the right hand side we integrate with respect to x. Integrating the left hand side, the integral of 1 divided by y minus 5 will be equals to the ln of y minus 5, and on the right hand side the integral of 3x divided by x squared minus 1. We can do it by the side, so we have the integral of 3x divided by x squared minus 1 dx. The integral, we are going to use the u sub method, and we can let u be x squared or we can let u equal x squared minus 1. So let's let u equal x squared minus 1, and derivative of u with respect to derivative of x will be equals to the derivative of the x squared is 2x, and the derivative of the negative 1 will be 0. We multiply both sides by dx, and on the left hand side that dx and that dx will cancel, and du will be equals to 2x multiplied by dx. Inside the integral we have the x dx, and we also have the x dx in that du. Let's divide both sides of the equation by 2, and du divided by 2 will be equals to x dx, which will substitute in our integral. We have this as equal the integral of 3 divided by x squared minus 1. In the place of the x squared minus 1 we substitute u. In the place of x dx we substitute du divided by 2 and this will be equals to, we can move the 3 divided by 2 out of the integral. We have that 3 over 2 out. Now we are left with 1 divided by u du, and this will be equals to 3 divided by 2 multiplied by the integral of 1 over u, which is the ln of u, plus the constant c. In the place of the u, we substitute back the x squared minus 1 plus the constant c. So let's copy and paste. So we have this as our general solution. So let's rewrite it. We have the ln of y minus 5 equals to 3 divided by 2 multiplied by the ln of x squared minus 1 plus our constant c. And this will be our answer for question 6.1. Question 6.2, we determine the general solution of this second order differential equation. On the right hand side, we only have the functions of x, the sine squared 3x, and no functions of y. So we won't be grouping the functions of y with the dy and the functions of x with the dx. Instead, remember that if we have y is equals to f of x, the derivative of y with respect to x will be dy divided by dx, and the derivative of dy divided by dx gives us the second derivative, the d squared y divided by the dx squared. Integration is a reverse of differentiation. So if we can integrate the d squared y over dx squared, we get back the dy divided by the dx, and if we were to integrate the dy divided by the dx, we get back the general solution, the y. Remember, the y is the general solution. So we are going to integrate our second order differential equation twice. So we introduce the integral both sides of the equation, and the integral of d squared y over dx x squared will be dy divided by dx equal the integral of sine squared 3x. We don't have a formula for the integral of sine squared in the formula sheet, but we do have a trigonometric identity for sine squared. So the trigonometric identity for sine squared, we take that one, the one which has sine squared, will be equals to the half minus half cos 2a. So the sine squared 3x will be equal to half minus half multiplied by the cos of 2a. So we have to multiply this 3x by 2, which will be 6x. We are going to integrate this with respect to x, and the dy divided by the dx will be equal to the integral of the half with respect to x will be half multiplied by x minus half multiplied by the integral of cos 6x, which is sine of 6x. If we were differentiating, we are going to multiply by the derivative of the 6x, the 6, but we are integrating, we are dividing by the 6 plus the constant c. Remember that we have to determine the original function y, so we are going to introduce the integral both sides of the equation again, and the integral of dy over dx is y equal the half multiplied by the integral of the x, which is equal to x squared divided by 2 minus half divided by 6. Half divided by 6 is equal to 1 divided by 12, and the integral of sine 6x is equal to negative cos of 6x. And again, if we were differentiating, we're gonna multiply by the derivative of the 6x, which is 6. Now we divide by the 6 because we are integrating, plus the integral of the constant c, which will be positive cx. That c is from the first integral. Now we have positive c2, the constant 2, from the second integral. We simplify and we have y is equal to half multiplied by half, which is 1 over 4 x squared minus, but that negative multiplied by negative will be positive. So here we have positive cos of 6x, and 1 over 12 multiplied by 1 over 6 will be equal to 1 over 72 plus 6 plus cx plus cx plus c2. And this will be our answer for the second question. Thank you guys for watching. If you have any questions, you can drop them in the comment section below. Remember to subscribe, like, and share the channel if you find this content useful.